experiment that is in the manual, which is the experiment for relative rates determination of electrophilic aromatic substitution reaction. This one I have changed to another experiment, but still related under the topic of electrophilic aromatic substitution reaction. That one I will explain later because I have created a new procedure and everything. That one you can get through the Google Classroom. Okay, I've put the new experiment over there. Okay, the procedures, objective, and so on. And I will brief on to you about that after this. But first, that I want to brief is the last experiment. Okay, experiment number 4 and 5. Which is qualitative analysis of organic compound. Luckily, last semester, you all managed to do the practical in the lab because your session was before the what do you call that, MCO started. So uh, the experiment is quite similar, but the only difference is the type of functional group test that you will be doing. Okay, so basically, if you are in the lab, I was supposed to give you unknown sample as well. Okay, in this case, two unknown. Okay, one unknown to be done in 1 week, and then another should be done in another week. Okay, two unknown, in which that you have to do all of these tests, which is the first one include the physical or preliminary analysis, in which you see the color and appearances, the smell of the unknown compound, and then you are going to test for the saturation or unsaturation. Okay, this one, if you still remember, you are going to test it using bromine water. So this is actually to check for the presence of double or triple bond in the organic compound itself. Okay, whether it can undergo addition reaction or not. For no aliphatic, so which is does not contain for saturated compound, it does not contain any double or triple bond, so the observation will be negative. That means you will not gonna see any changes with the color of bromine. So that is for bromine water test. And then you have this Bayes test. Okay, and number 3 will be for the aromaticity. So this is to check whether the compound is aromatic or not. Okay, in theory, you can determine whether a compound is aromatic or not by uh, what you call that, determining the compound is following Haeckel rule, whether it is in planar, whether it's contain conjugated double bond, and so on. But in experimentally, you can actually do a testing, do an analysis, which is this nitration test, okay, to determine whether the compound is aromatic or aliphatic or not. Okay, still remember this reaction. If the compound is aromatic, it will sort of like releasing very vigorous bubbling in the test tube. Okay, that's why I asked you to do the testing inside the fume hood. Okay, because it is can be classified under isothermic reaction, so it release a lot of heat. So sometimes the tiny explosion may be too big, so it kind of like spill out of the test tube itself. But it only lasts for a few seconds. After then, the reaction will subside and temperature will start to go down again. And then for the functional group test, okay, there are test that you'll be doing for carboxylic acid, phenol, and also amine and amide. Okay, so the first one is the carboxylic acid, in which there are 4 tests, which is the effervescent test. So this is basically just mixing the carboxylic acid with sodium bicarbonate solution. So this is one of the tests that you can do to differentiate between carboxylic acid and also phenol. Okay, phenol is also slightly acidic, but then again it can only react with uh, uh, sodium hydroxide. Okay, for example, not bicarbonate salt. Okay, so effervescent test is one of the example of one chemical test that you can use to differentiate. Okay, and then ester test. So in ester test, the carboxylic acid, if you mix with alcohol, for example, in this case, ethanol, so this one will produce an ester, okay? But for phenol, you cannot, for phenol, if you want to convert it into ester, it does not follow the same reaction reagent, in which you cannot straight away mix phenol with with carboxylic acid, and then with the presence of sulfuric acid or strong acid. So that will not change phenol into ester. Okay, so that is one of the other example in which you can differentiate between carboxylic acid and phenol. And then we have this phenolphthalein test. Okay, you add phenol and also concentrated sulfuric acid, and then heat and cool and pour into the dilute sodium hydroxide. So this one also should be done in the fume hood, as it involve um, what you call that, concentrated sulfuric acid. Okay, so the observation should be pink color will be formed. So it could be a dicarboxylic acid, and then another one is fluorescein test. So this will use resorcinol, okay, which is benzene ring with 2 hydroxy group. Okay, so this one also can be used to determine whether the compound contain uh, 2C double bond OOH. Okay, so this is for dicarboxylic acid. Okay, phenolphthalein test and also fluorescein test. And then for phenol, okay, this one, the first test is the iron chloride test. Okay, and then you have the Lieberman's reaction, the Lieberman reaction. So only 2, but actually we can also do it for effervescent, but the effervescent will give you negative observation, as in it will not, there will be no breeze effervescent being formed because there is no reaction. Okay, and the third functional group that you will be testing is for primary amine. Okay, there are 4 tests, which is acetylation, okay, benzylation, and then dye test, and carbyl amine. Okay, and lastly, this is actually a carboxylic acid substituents. Okay, C double bond O N. Okay, for amide. So there are 3 tests. The first one is just mixing it with sodium hydroxide, and the observation is that ammonia is involved. So basically you are trying to detect the smell, because ammonia, the smell is not pleasant. Okay, sort of like fishy smell. Okay, so the observation is more on the gas that is being evolved. So ammonia is in gas form. So you are not trying to check if the precipitation or color changes. It's just more of the gas being released. And then you have burette and also reaction with nitric acid. And lastly is the reaction with oxalic acid. Okay, so the sample, if the sample gives out a white crystalline precipitate, then it could be diamide. So diamide meaning it contain two C double bond O N groups, okay, in the same compound. So in the Google Classroom, let me open the Google Classroom first. Okay, for this particular experiment, you are not going to do, you're not able to do the each of the tests itself, but what I want you to do is to share a video link for the test that is available in the manual. Okay, I have counted, there are a total of 19 tests. Okay, so there are 16 of you, so you should uh, share at least one test each. Okay, but if possible you can share maybe two, okay, so that all of the 19 tests will be covered. 19 minus 1, okay, I give one example over here. So there are 18 left. Okay, so try to cover all of the 18 tests. Okay, example like these tolerance. Let's see for a while. So this tolerance is actually for aldehyde test. Okay, for aldehyde test. So it's not available in your this semester's manual. Sorry, yeah.
This video demonstrates how to use tolerance reagent to test for aldehydes. This video first demonstrates the preparation of tolerance reagent. Two tests will then be carried out. One shows a positive result, and the other shows a negative result. Preparation of tolerance reagent. Add 2 milliliters of 0.3 molar silver nitrate solution into a clean test tube. And then add 1 to 2 drops of 0.3 molar sodium hydroxide solution. Brownish precipitate of silver oxide will be formed. And a 3 molar aqueous ammonia solution drop by drop with a dropper, until all the silver oxide precipitate is just dissolved. Do not add excess amount of the ammonia solution. The solution obtained is aqueous diamine silver solution, which is also known as tolerance reagent. Add a small amount of sample to the tolerance reagent. Shake the mixture gently. And then stand it on the bench for 10 minutes. Observe if there is a silver coating formed on the inner surface of the test tube. If there is no observable change, warm the mixture in a warm water bath for 5 minutes. If the sample is an aldehyde, a positive test result will be obtained. If the sample is not an aldehyde, the test will give a negative result. It is important that tolerance reagent should be freshly prepared. Prior to disposal, the reagent must be acidified immediately after use. The addition of acid prevents the formation of explosive supernitride.
So that is an example of videos that you should share. So okay, so there are 19 tests. So you can put the link in the comment section. So I just want you all to put the link on the comment section below over here. Okay, so I hope to see there's 19 links in the comments. Okay, but not all 19 from one of you, so all must participate. Okay, and in terms of the uh, reporting, okay, so this is slightly different than what you're supposed to be. Originally, I should give you unknown compound, and then you are going to do all the testing to determine what kind of organic compound it is. But now, I am giving you the compound itself, the name of the compound, and what you should do is basically, for example, like the first one, anisidine. So you are going to check in the let me open back the manual. Okay, in the manual. So below over here, what kind of observation that you are supposed to see. Okay, for example, like an anisidine. Let's say it is an aromatic compound. Okay, so you have to check what is an anisidine, what is the compound, what is the functional group. So let's say it is an aromatic. So you should write over here the observation should be positive for an aromatic compound. Okay, and then let's say it contain a primary amine group, so that should be here. Okay, so things all of the tests that should be positive for that particular compound, so you can write the positive observation. Okay, so there are uh, four sorry, so there are, I put here four group. That means there are 16 of you. So 4 person will choose these two compound. Okay, another 4 will choose the compound from group 2, and another 4 will choose uh, compounds from group 3, and the last from group 4 lah. So that means all of you will be doing different compounds, so not the same compound. Okay, so group 1 will be on anisidine and phenylmethanol. Okay, and group 2 will be catechol and adipic acid. Group 3 will be toluidine and hydroquinone. Group 4 will be cresol and nicotinamide. Okay, so you are supposed to uh, report what kind of positive observation that it should give if you are actually doing the testing. Okay, so up until now, if you have any question, you can ask regarding the first task. Any questions? Is it clear? Tak ada soalan? Okay,
Sir, so yang satu group ada 4 orang kan? So satu group tu akan dapat 2 sampel. So dalam satu group tu kena cari 19 test yang kita punya sampel lah
No.
Is it?
Bukan. The compound that I give to you is for the report. It's for your report. And that should be done individually lah. Group tu saya bagi supaya 4 orang will get these 2 compounds. Another 4 will get the different 2 compounds. The test should be shared in the Google Classroom. So that is also kind of like individual. So each of you, I want you to share at least one test lah. Not
Oh, maksudnya
not
any ke?
yeah,
Any.
any just that the test is generic lah. Bukan untuk compound awak. Kalau awak saya suruh awak share untuk compound awak, memang awak tak jumpa lah.
Oh, itulah saya.
Uh, just a
Okay,
generic
okay.
test. Let's say
Understand.
untuk burette. So you just find a video for burette test and then share in the link. And
Okay.
I want you all to watch all of the, once everyone has shared, I want you all to watch all of the testing because you are not going to do it in the lab. Okay, we never know when you get the chance to do it. So I want you to watch, especially for the functional group test because the nitration semua tu you all dah pernah buat. Okay, especially for the functional group test. Okay, anything else?
Thank you, sir.
Ada yang lain nak tanya? If no, then I will brief to you about the first experiment, which is sorry, wrong one.
Sir,
Yeah.
yang kan ada like instruction yang suruh please compare and take note of any differences, right? So for this one, should we include the like discussion?
You can include, but that will be individual lah. So in your report, you can jot down in the report. Maybe in the procedure also you can put.
Alright.
Just put in the procedure, so the procedure is slightly different. Okay, so sorry, okay, this one. So the soft copy for this experiment I have put in the Google Classroom, so you can download it later. Okay, so I have changed the first experiment to Friedel-Crafts alkylation of 1,4-dimethoxybenzene. So as the original one do not have any video resources, so uh, uh, I'm afraid that you will not be able to grasp what is you are supposed to be you are actually supposed to be doing in the lab. So I've changed, but in a way that it is still under the topic of electrophilic aromatic substitution reaction, but this time it will be Friedel-Crafts alkylation. Okay, so the objective is to conduct the alkylation of 1,4-dimethoxybenzene. Okay, it is benzene with two substituents group of alkoxy. So one position number 1 and position number 4, which is para lah. Okay, para. So this is the first part on the principle is basically like a note on electrophilic aromatic substitution reaction, more like all of the what you call the mechanism and so on. Okay, so the limitation of this reaction, which is Friedel-Crafts, okay, they have limitation, right? As you can also refer that in the note. Like the first one, carbocation ion electrophiles. Okay, the carbocation ion can rearrange before undergoing electrophilic aromatic substitution. Okay, based on the cation stability. So if it is for the primary, it can maybe the electron may shift to produce a secondary or tertiary carbocation ion, which is more stable. Okay, and then if you have strong electron withdrawing groups, it will prevent the reaction from happening. You may get very small yield, or there could be no reaction whatsoever. Okay, example like an amino groups. Okay, so that is the second limitation. And then aryl and phenyl halides will fail to react as they do not form carbocation ion at all. Okay, because the of the presence of the double bond. Okay, so very hard for them to form carbocation because it is already electron rich. And then polyalkylation, meaning that it does not stop with one substitution only, so it will keep on substituting. Okay, once you get the product, that product will become the starting material again, so that another hydrogen will be substituted. So all of this can be overcome by instead of doing alkylation, you can opt for acylation reaction. Okay, but for this experiment, actually is doable. So if you still remember, the reagent for an alkylation is normally you use uh, alkyl halide with the presence of catalyst like or Lewis acid of aluminum chloride. But in this reaction, um, the reagent that you'll be using is not an alkyl halide but an alcohol. Okay, if you refer to the note, you can also do alkylation with either alkene or alcohol, but the reaction condition will be slightly different, in which that the temperature is different, and also other organic compound added is also slightly different. Okay, material used will be the starting material itself, which is 1,4-dimethoxybenzene, and then 3-methyl-2-butanol, which the organic compound that you want to substitute into the benzene ring, and then glacial acetic acid, concentrated sulfuric acid, and also methanol. Okay, basically here the procedure, the reaction will be done in a 100 ml round bottom flask. So it is a flask with a round bottom. Later in the video you can, I will show you what is the shape of a round bottom flask. And then you need a stirring bar or magnetic bar, uh, which you will add 2 gram of this 1,4-dimethoxybenzene, and also 3.2 gram of the butanol. Okay, so in this case you can convert the weight into ml, because the alcohol will be in liquid form. If it's in liquid form, you can convert into volume by knowing the density or specific gravity of the compound, or you can just weigh in a small, very small beaker using an analytical balance. Okay, and 10 ml of glacial acetic acid. So all of this will be mixed together in a round bottom flask. So stir and cool with an ice bath. So basically the reaction need to be at low temperature, so you need an ice bath to cool it down before adding concentrated sulfuric acid. So this have to be added slowly, so you don't add all 10 ml at the same time, so it has to be add dropwise. So once all the acid has been added, sulfuric acid has been added, you will leave it to be stirred for another 20 minutes. So then cool again the reaction mixture before adding distilled water, about 50 to 60 ml. Okay, then you are going to filter. So this is done by using normal gravitational filtration or suction filtration. Later in the video that I will show you, it will use the suction filtration. It is faster and also much more efficient than gravitational. So once you have filter, you will get the crude product, okay, crude product or raw product. So that will be recrystallized again. Okay, as all of the synthesis experiment, you need to recrystallize again. When that one, you have to recrystallize with methanol. So how much methanol that you want to add is basically, as I said in previous reaction, just enough so that you can dissolve the crude product that you obtain. Okay, because the crude product obtain may be different from one person to another. Some of you may get a lot, some of you may get very little. So here it is state to add the methanol in 5 ml increments. So you add 5 ml first, see whether it is enough to dissolve. If it's not enough, then you add another 5 ml. And then after you add, you have to cool it down in an ice bath, filter again, and the product will be dry before you can record your yield. Okay, so this is the observation that you the raw data I will share in the Google Classroom. Later I will show you. And just some question that I posed over here. So what kind of functional groups that you can introduce by Fiddlecraft reaction? And if you notice that in this manual, I did not give any reaction scheme. So basically what you have to do is you have to find out what is the structure of 1,4-dimethoxybenzene and what product that you should obtain. So draw the chemical structure and give the IUPAC name of the product. Okay, so you have to find out the reaction pathway or the reaction equation for this experiment for the synthesis. Okay, and then in the dye substitution reaction of the reaction above, formation of the new carbon-carbon bond could result in 3 isomers around the benzene ring, okay, which is auto, meta, and para. So what are the roles of auto, meta, and para directing effects and steric effect that cause only one isomer to be formed in the reaction? Okay, meaning that there is only one product that will be obtained instead of you can get probably 3. Okay. So, and lastly, provide the mechanism for the reaction in the experiment. So, the mechanism is basically you can use the general mechanism as a guide, just replacing with the compound. Okay, starting material will be different, and the substitution or substituents that coming in is different. Now, for the material, uh, so over here I have put in the Google Classroom the new manual, and also over here some notes on recrystallization techniques. So basically this is the general notes on why you should do recrystallization and what are the general method that are normally being used. So please read. So because this can be applied for the reaction for synthesis of benzotriazole and the coumarin synthesis as well. Okay, and the raw data has been given over here. So we have weight of the starting material. I have put as 2.04 gram, and weight of 3-methyl-2-butanol also has been given 3.23 gram. But I do not give the weight of the product, but I give over here, find out weight of the product if you were to obtain 78% yield. So this is like reverse calculation. So instead of finding the percentage yield, I want you to find out what is the weight of the product that you should get if the yield is supposed to be 78%. Okay, understand? Faham tak ini? Normally I will give the weight. Okay, normally I will give the weight of the product. You have to find out the yield. But now I give out the yield, so you have to find out weight of the product over here. But first you must know the theoretical yield. That one can be calculated from this two information given here, which you need to convert to mole first. Okay, for the videos, let's see.
Okay, welcome back to doing today.
I'm just gonna skip first.
And use a powder from my 1,4-dimethoxybenzene weight out here. Use a powder funnel, please. Little top. In she goes. I have the alcohol, the 3-methyl-2-butanol. And that one goes. Weighed that out previously. So here we go. Our solvent for a reaction, glacial acetic acid. And that goes. So now would be a good time. Let's get our ice bath prepared and stirring. A reaction involves adding sulfuric acid to make it go. Sulfuric acid, when it's added to anything, generates a lot of heat. So, cooling, very important. Stirring, not too fast, or the stir bar will just dance around. Okay, and so we're ready. Sulfuric acid. Be careful with this stuff. If you get some on, just quickly wash it off, but boy, it can hurt a little bit. So, no big deal. Carefully, in goes the sulfuric acid. Now, I've got a lot of glassware here that's got acids and stuff all over it. Let's clean it up right now.
So if you look, actually, in most of the videos, you find out that all of the demonstrators do not wear gloves while handling chemical material, chemical compound. So basically, if you were to go to a normal like chemical laboratory, so it is not actually advisable for you to wear glove, because some of the gloves, like for example, like rubber glove, are very bad quality. If you get any solvent or any liquid chemicals, they kind of like seep into the inside of the glove, so which make it worse because you do not notice the compound has got into contact with your hand. If you were not wearing glove, if it's got into contact with your hand, you can straight away know and wash it. So that's why in most chemistry labs, okay, like pure chemistry lab, they do not use gloves, okay, but lab coats and safety goggles. The most important thing is safety goggles, because you don't want to get anything spilled to your eyes.
Okay, so everything's nicely rinsed. No stray acids to cause trouble. So, this time we're going to be adding our sulfuric acid slowly. Remember, there's going to be a lot of heat generated here. We're looking for 2 or 3 drops a second. Get that going. Keep the stirring. There. Now we wait. In the meantime, we are going to have to do a recrystallization. So I've got one set up right here. Here's some crude product from before. I have about 5 grams here. And as it says, we need about 5 milliliters of methanol per gram of compound. So here we go. I'm just going to add the cold methanol to my solution. And whenever possible, and you're going to boil something, boil using water. That way you're less likely to have a fire, but at the same time you can control the heat a little bit better. Remember, we're not making tea. You just need a little bit of water in your beaker. Alright, our addition is now done. I'm going to close that. Carefully take that off. And we want to stir at room temperature for a while. So I'm going to take the ice bath off of there and just let that stir. So, 15, 20 minutes, let it warm up to room temperature. All will be good. Excellent. In the meantime, this is contaminated with sulfuric acid. Wash it before you hurt yourself, please. So, we did our 15-20 minutes at room temperature, and now we need to cool it down again, and we're going to quench. Now, adding water concentrated acids causes a lot of heat evolution again, so gotta make sure it's nice and cold, and cautiously Add the quenched water, 50 or 60 milliliters. A beaker is good enough to measure this quantity. And if all goes well, that will just help precipitate our product out of the acid mixture. Good. No worries. There we go. So when that's done, let it cool for a bit if necessary, but that seems to be just fine right there. So now it's time to filter. Setting up with your filtration apparatus, clamp, turn on a little bit of vacuum. Once again, swirl and pour. Wait for it. And we just wait for that to go through. Okay, so we've got our filtration of our crude product done here. That's to wash with cold methanol. The best way to cool your methanol is take the bottom off the grad cylinder and put it in the beaker of cold water. So we have our crude solid here. I'm going to break the vacuum, add the cold wash solvent, put the vacuum back on, and suck it dry. Let that sit for a couple of minutes. So here we are, we've been boiling away like mad, not paying any attention at all. And guess what? The methanol's been evaporating and the solid hasn't been dissolving. We have to add more methanol to get it to dissolve. So just stand by, I'll go get some more. This is the tricky part about recrystallizing. You're never really sure how much solvent you're going to need, but if it's boiling and it ain't dissolved, you're either trying to dissolve the salt or you have to add more methanol. There, hopefully that will do it this time. We'll keep a closer eye on it this time so the methanol doesn't evaporate away. But hopefully this will now completely dissolve and then we'll be able to cool it and get nice crystals to filter. So see how that's boiling like mad? Normally, if you had enough solvent, the solid would have dissolved by now. It's boiling, it's not dissolving. Guess what? You need more solvent.
See, he keep on adding solvent to make sure that all of the crude product dissolve. Okay, so just enough. So that is the videos for the experiment that I have changed. So you can rewatch it again later because besides showing